It was the last question which I didn't get to do.
Which one?
In where?
The last bullet one?
Wait, wasn't it? Or am I thinking of another class? No, I'm mixing you up with my other physics students.
So how did you know that was a bad book?
I don't know, actually.
Yeah, right now.
No, it is a bit odd. Yes.
The one you did yesterday.
You did the bullet holes.
Yeah, but did I say it was lead?
Yeah. Yeah.
I actually said that in the question. It doesn't matter.
Circular motion.
No, collisions now. Right.
Oh.
An 80 kilogram physics student steps off a 200 kilogram boat at a speed of 2 meters per second. How fast will the boat move away? So before the student steps off, the mass of the student is 80 and their velocity is 0. Oh, sorry.
He's moving with the boat, so he's on the boat, so he's...
Physics steps off. Yeah, I know, but at the student is on the boat. That's the before collision, and then afterwards they step off with 2, and the boat moves away.
So he's 0.
So he's 0.
No.
Yes.
No,
And the boat is 0.
Yes.
And then when he steps off, that's the collision. It's 80, and it's a 2 plus 200 x.
Yeah?
Yeah.
He's on the boat and the boat is moving.
No.
The boat is stable.
No, let me speak. He's on the boat and neither are moving.
Okay.
He steps off the boat and the boat recoils. This is the collision.
Okay.
So x equals minus 160 over 200, which is minus 0.8.
Yeah.
Is it?
Yeah.
Okay.
Oh, but is it a minus?
Yep. Yes, because the boat must move opposite to him. If he steps to the right, the boat will move backwards. It's a minus, look. Can I continue now? Yes. What?
Why is that not minus 0.8?
Oh, my minus fell off. Okay, 2. An 80-gram bullet leaves a 2-kilogram shotgun at a speed of 200 meters per second. So before the collision, and what's the collision here?
Before 0.
Yeah, what would you say it is in the firing?
It's
Yeah, it's the hammer striking the bullet,
Yeah.
causing the bullet to fire out and the gun to move back. So before the firing, you have M1 0 plus M2 0. It's just like the last one. 2x plus 0.080 times 200. Yes? For the answer?
No. 0.04 is the answer.
8 is the answer. Isn't it?
Never mind. Yes, it is.
No, I can't trust you.
Yes, it is.
Trust you?
Calculate.
Minus 8 meters per second.
Where did the 0.08 come from?
That's the mass of the bullet.
M1U1 plus M2U2 equals V1.
No, he's just confused by how much 80 grams is. Doesn't matter.
Yeah. So how can it be minus if the bullet is going?
The bullet you're finding the speed.
Which
of
way does the gun go when you fire it?
Oh, it goes
backwards.
so we're
Listen. 3. A water hose is lying on the grass. The nozzle and hose have a mass of 1 kilogram. A boy turns the water on and the water leaves the nozzle at a rate of 2 litres per minute. During the first second, how far does the nozzle and hose recoil if the water comes out at 2 meters per second? So what happens here is you have your water hose and there's water that comes out at 2 litres per minute. So that's 2 kilograms per minute. That's 2 over 60 kilograms per second.
You converted liters to kilograms?
Yeah, because a litre of water is a kilogram in mass.
Oh.
Yeah. We are only looking at the first second. So in 1 second, some water that's in the hose. How much water? Well, this one here, yeah. That fires out. So what should happen with the hose? Naturally should fire back. So again, conservation of momentum. M1, the mass of the water, times U1, plus M2, the mass of the hose. What's the mass of the hose? Yeah, 1. That's equal to, now, I tell you the speed of the water, it's
2 meters.
2. And we want to know what is the x here, how much the hose recoils. So the answer is x equals minus 1 over 15 meters per second. Okay, again we're just using the good old M1U1 plus M2U2 equals M1V1 plus M2V2. I hope so. Right?
50.
Can I do 4 now?
One.
If I want. I think I will. 4. A male skater of mass 65 kilograms is moving towards a female skater of mass 50 kilograms. He is moving at 2 and then she is moving at 4.
I wish the wall worked this way.
Please move as fast as you move.
Thank you. He is skating at 4 and she is at 2. They move off together. Find their velocity. So we have M1 U1 plus M2 U2 equals 115 V. Yes?
I know.
Good for you. So what did you get for V? You can help me.
13.
Meters per second. We must show that this collision is inelastic. The kinetic energy of the boy is a half m v squared. And then the kinetic energy of the girl is a half m v squared. So what's the total kinetic energy before the collision?
620
Joules. And then the kinetic energy after is a half 115 3.13 squared, which is,
563
what is it?
563
Which is less. So the kinetic energy after is less than the kinetic energy before, which makes it inelastic.
If they ask us in the exam if it's elastic or inelastic, can we just guess? Because like it's almost
If
probably
they don't have the
inelastic.
same mass,
Would they ask us to explain?
I can't see into the future.
No, like have they done it before?
I don't know right now.
Okay.
It's only going to be 1 mark. These are not the questions to be asking right now. Okay. Next one. Right, what one are we on now? 5. Right, this last one's a bit hard, so I don't know, did anybody get it?
I think I did. I think,
What answer did you get?
for, A, 97.8,
Yes.
And B?
487.5.
I don't know.
487.5.
Yeah, I think that was too bad,
Pretty long pendulum.
but at least I have an answer.
Yes, okay, let's have a look here. Alright, you have an 80 gram bullet which is 0.08, right Yusuf?
Okay, yeah, that's wrong.
No, is it really?
Oh,
I did wrong.
oh, hi, it.
I did, yeah.
0.08.
This from.
You too! Oh. And it hits a 1 kilogram block at the end of a pendulum. So what will happen is this will get stuck into the block and the two of them move together. Let's calculate their speed. M1 M1 U1 plus M2 U2 equals 1.080 V. So you both made the same mistake. That's why you have the same answer. So your V will be different now. Did you recalculate it?
Yeah, but the only difference would be like a decimal place.
16.
Tenfold difference is pretty big. What is it?
16.3.
16.3.
I just missed something.
Is that right? Can I trust you, Fawn?
Trust me.
No. 0.
Every time you trust me and now you not trust me.
Yeah, I don't know. 1.08.
Sure.
No, no.
I trust you. Right. That's the first answer. Yep. The second one is a little bit harder. Can I scroll down a bit? Do you have this, Andrew? You have this?
What's the last word?
Yeah, I got a bit cut off, but it would have just saying after that collision. Okay. Continuing. So now what you have is you have this situation. You have the mass of 1.080 moving with a speed of 16.3. And this is going to swing up to some height. And we want to know this height here. So what is this? Conservation of energy. What energy does it have here? Yeah, kinetic. And what energy does it have here? Potential. It's at rest up here, so there's no kinetic. So, a half m v squared equals m g h. So I can cancel that with that, and I can get h is 16.3 squared over 2 times g. $13.5 meters.
If only I had the speed right.
Yeah, probably. Huh?
Really?
What? What are you asking me?
Seems like it's just so fast.
I just make it look easy.
No, the last one, the time.
You think? What time are we at now? We've got time to do a little bit more. Hmm?